Row 1. Text, Notepad window, text editor, editing. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just close eyes and listen. Based on G scheme for electronics engineering group. Subject, microcontroller, 17,534. These are mostly important questions which is always repeat. Form top to end it, reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Microcontroller Chapter 2. 1. D. Compare 8031, 8051, 8751, any 4 points. ANS 1x 4 marks for each difference. B. Describe the power-saving modes of 8051 microcontroller. ANS, diagram, 1 mark, PSEN format, 1 mark, explanation, 2 marks. Microcontroller Chapter 2. 2. Idle mode. In the idle mode, the internal clock signal is gated off to the CPU, but not to the interrupt, timer, and serial port functions. The CPU status is preserved in its entirety, the stack pointer, program counter, program status word, accumulator, and all other registers maintain their data during idle. The port pins hold the logical state they had at the time idle mode was activated. ALE and PSEN hold at logic high levels. There are 2 ways to terminate the idle mode. I. Activation of any enabled interrupt will cause PSEN.O to be cleared, and idle mode is terminated. 2. Hardware reset, that is, signal at RST pin clears ideal bit IN PSEN register directly. At this time, CPU resumes the program execution from where it left off. Power down mode. An instruction that sets PSEN.1 causes that to be the last instruction executed before going into the power down mode. In the power down mode, the on-chip oscillator is stopped. With the clock frozen, all functions are stopped, but the on-chip RAM and special function register are maintained held. The port pins output the values held by their respective SFRs. ALE and PSEN are held low. Termination from power down mode, an exit from this mode is hardware reset. Reset defines all SFRs but doesn't change on-chip RAM. Three. The 8051 contains 210-bit addressable locations, of which 128 are at locations 20H to 2FH, while the rest are in the SFRs. Each of the 128 bits from 20H to 2FH have a unique number, address, attached to them, as shown in the table above. The 8051 instruction set allows you to set or reset any single bit in this section of RAM. With the general purpose RAM from 30H to 7FH, and the register banks from 00H to 1FH, you may only read or write a full byte, 8 bits, at these locations. However, with bit-addressable RAM, 20H to 2FH, you can read or write any single bit in this region by using the unique address for that bit. General-purpose RAM. These 80 bytes of internal RAM memory are available for general-purpose data storage. The general-purpose RAM can be accessed using direct or indirect addressing mode instructions. Special function registers, SFRs, locations 80H to FFH contain the special function registers. As you can see from the diagram above, not all locations are used by the 8051.11. Locations are blank. These extra locations are used by other family members, 8052, etc., for the extra features these microcontrollers possess. Microcontroller Chapter 2. 4. C. Describe the function of following pins of 8051 microcontroller. I PSEN, 3, RST, 2, EA, 4, ALEANS. Each correct function, 1 mark each. Function of PSEN. 1. PSEN stands for Program Store Enable. The read strobe for external program memory is the signal PSEN, Program Store Enable. In an 8031-based system, in which an external ROM holds the program code, this pin is connected to the OE pin of the ROM. 2. In other words, to access external ROM containing program code, the 8031/51 uses the PSEN signal. This read strobe is used for all external program fetches. PSEN is not activated for internal fetches. Function of EA. 1. EA, which stands for external access, is pin number 31 in the DIP packages. It is an input pin and must be connected to either VCC or GND. In other words, it cannot be left unconnected. 2. The lowest 4K, or SK, or 16K, bytes of program memory can be either in the on-chip ROM or in an external ROM. This selection is made by strapping the EA external access pin to either VCC or VSS. 3. In the 4K byte ROM devices, if the pin is strapped to VCC, then program fetches to addresses 0000H through OFFFH are directed to the internal ROM. Program fetches to addresses 1000H through FFFFH are directed to external ROM. 4. If the pin is strapped to VSS, then all program fetches are directed to external ROM. The ROMless parts must have this pin externally strapped to VSS to enable them to execute properly. Function of reset. 1. Pin 9 is the reset pin. It is an input and is active high, normally low. Upon applying a high pulse to this pin, the microcontroller will reset and terminate all activities. 2. This is often referred to as a power-on reset. Activating a power-on reset will cause all values in the registers to be lost. It will set program counter to all zeros. 3. In order for the reset input to be effective, it must have a minimum duration of 2 machine cycles. In other words, the high pulse must be high for a minimum of 2 machine cycles before it is allowed to go low. Function of ALE. 1. ALE stands for Address Latch Enable. It is an output pin, and is active high for latching the low byte of address during accesses to external memory. 2. The ALE pin is used for demultiplexing the address and data by connecting to the G pin of the 74LS373 chip. Microcontroller Chapter 2. 5. IEA/VPP2, ALE/prog. Function of EA/VPP1. EA, which stands for External Access, is pin number 31 in the DIP packages. It is an input pin and must be connected to either VCC or GND. In other words, it cannot be left unconnected. 2. The lowest 4K, or SK, or 16K, bytes of program memory can be either in the on-chip ROM or in an external ROM. This selection is made by strapping the EA, external access, pin to either VCC or VSS. 3. In the 4K byte ROM devices, if the pin is strapped to VCC, then program fetches to addresses 0000H through OFFFH are directed to the internal ROM. Program fetches to addresses 1000H through FFFFH are directed to external ROM. 4. If the pin is strapped to VSS, then all program fetches are directed to external ROM. The ROMless parts must have this pin externally strapped to VSS to enable them to execute properly. Function of ALE/prog. 1. ALE stands for Address Latch Enable. It is an output pin, and is active high for latching the low byte of address during accesses to external memory. 2. The ALE pin is used for demultiplexing the address and data by connecting to the G pin of the 74LS373 chip. IT0, it is I/P signal to internal timer 0 circuit. External clock pulses can connect to timer 0 through this I/P signal. It is pin number 14, P3.4 pin of 8051-2, INT0 /. There are two external hardware interrupts INT0 and INT1. INT0 has the highest priority of 1 and timer 0 comes next with priority value 2. The order of priority works like this. Consider a case where two interrupts are raised at the same time, one from INT0 and another from timer 1 interrupt. In such a case, processor would serve the interrupt according to its priority. In our case, INT0 is of high priority, priority order 1, and timer 1 interrupt is of low priority, priority order 4. So processor will execute ISR of INT first, and then later, after finishing ISR of INT0, processor will begin executing ISR of timer 1 interrupt. B. List important any 8 features of 8051 microcontroller. ANS. Any correct 8 points, 1/2 mark each. Features of 8051 microcontroller are as follows: 1. 8-bit data bus and 8-bit ALU. Microcontroller Chapter 2. 6. 2. 16-bit address bus, can access maximum 64 KB of RAM and ROM. 3. On-chip RAM minus 128 bytes, data memory. 4. On-chip ROM, 4 KB, program memory. 5. For 8-bit bidirectional input/output ports. 4 8-bit bidirectional input/output ports. 6. Programmable serial ports, i.e. 1 UART, serial port. 7. 2 16-bit timers, timer 0, and timer 1 8, works on crystal frequency of 11.0592 MHz. 9. Has power saving and idle mode in microcontroller when no operation is performed. 10. 6 interrupts are available, reset, 2 interrupts timers, i.e. timer 0 and timer 1, 2 external hardware interrupts INT0 and INT1, serial communication interrupt for both receive and transmit.